Okay, let's get started. Okay, so let's see what's up. PS4 is out. It's due Thursday or Friday, usually late day. And it involves modifications to both PS2 and PS3. I remembered wrong last time. It doesn't involve necessarily regular expressions. You're required to use the ones. At the same time, the grades for PS3, we're working on the grading test throughout. So you can see what you can run your PS3s against them. PS2, the grades are out, and if there are any regrade requests, there's PS2R for doing that. So a lot to think about at the same time. Remember, these regrade things have deadlines. I set it a week after when we release grades. So PS2R, if you're doing a appeal, is due Friday. Yes?
We get there's like 2 or 3 late days, 3 late assignments for this, right?
You get 3 late days for the first 6 assignments.
So the first 6.
Yeah.
And then that doesn't apply to the other ones?
No, then after 6 we turn into pairs, and then we'll restart. I'll give you probably 3 late days for your pairs. Yeah. And I'm glad we brought that up. So, so we're on PS4, PS7, you'll be working with a partner. So you need a partner. It's not optional. So if you don't have a partner, you can start asking around, try to line those up. Any questions or problems? Yes?
So when I merged my PS3 with the grading test and then the one I had made, for whatever reason, all of the tests fail. But if I copy them into my test case that I used originally, then they succeed.
Well, that's hard to diagnose without looking at your solution.
Yeah,
so.
I assume there was something that went wrong in the merge.
Well, there may have been a conflict, maybe with some reference you got replaced. It's hard to say.
I mean, I checked my references, and it still got like a reference to the dependency graph class and everything.
Yeah, I mean, if you want to bring it by, I can look at it or one of the TAs. Merges can be tricky sometimes. Any other questions? Okay. Well, we're going to talk about a variety of topics today. First one is performance. And so the questions I'm thinking about, the large questions, are what should you do if your program is too slow? Or what should you do if your program uses too much memory or runs out of memory? What are ways to improve performance in various ways? And tell me, if your program's too slow, what do you do? Yeah.
Try a different data structure.
Okay, he said try a different data structure. I'm also teaching 4150 right now, trying to convince the students in there that that stuff matters by giving them assignments that they can't complete if they don't use the right data structure because they run out of time on my tests. So stuff you learn in 2420 with algorithms, it really matters. It really affects performance, sometimes incredibly much. What else? How else can you improve performance? Yeah?
If you have any other programs running on your computer, you should probably turn them off.
Okay, I mean that doesn't, so turning off other programs that are running might make it okay on your computer. It's not going to improve the performance of the program, but improve the performance of your computer certainly. What else? What else do you do? Yeah?
Better hardware?
You could. I mean, you could get that's related to what she said, you could get a faster computer. And, before you laugh about it, suppose you're in some business and you got some program that you've invested millions of dollars in that you're using in-house, and it's not fast enough. An easy way to speed it up might be to get better computers. Maybe not. Nowadays it doesn't work as well as it used to. But that could be cheaper than anything else. Okay. What's another way to improve? Yeah.
If you have a program that takes a long time and you're calling it frequently, maybe call it once and then store the value and use that.
Okay, so caching previously computed values, I guess that's sort of like using a better data structure, better algorithm. Any other ideas? Yeah?
See if you're doing anything
Okay, look for, try to improve your code. Yeah?
Well, I mean, trying to improve your code more specifically in the fact of making sure it doesn't always go through the same kind of procedures again if it's unnecessary.
Okay, so eliminating unnecessary code. I mean, these are all good ideas, so let's think about it. So one idea for improving your code is to do low-level code tuning. You make small-scale changes to the code, hoping to make it run faster or smaller. We'll look at that in more detail in a second. There's method design, which was mentioned. Choose a better algorithm. Class design, choose a better representation. That's data structures. Program design, maybe you rethink the way the program is divided into pieces. I mean, these become increasingly hard to do. No one mentioned this, is to make your program multi-threaded. Make it so that 2 or more things are going on at the same time. Nowadays, that's an important way to speed up performance. Operating system interactions. Sometimes you got a slow program simply because it's doing a lot of input and output, or other operating system things which take a long time. Maybe you just need a better compiler. Or, if you're like in Visual Studio, just change from debug to release. And that could speed it up enough. Or buy a faster computer. All right, this is code tuning. So, let's say that first assignment, x gets a plus b divided by 2. What could you do to speed that up? Suppose you decided that was the source of all your troubles. Yeah? You got an idea?
Perhaps use like bitwise shifting.
Okay. There are bit shifting operations, and if you add a and y and then shift it right by 1 bit, you're basically throwing away the low order bit and dividing by 2. So you shift on a 0 at the left and you shift off the bit on the right. Makes it slightly faster. Could that make a difference? The difference between the cost of a division and the cost of a bit shift?
I
Yeah.
think if you're doing a million of those, like if you have a loop of a million of those, I
Okay.
think that'd make a pretty big difference.
So if it's in the middle of the loop, that's doing a lot of it, can make a difference. What about the next one? You're doing a plus b times a plus b. Yeah?
It might use more memory, but you can store the result of a plus b in the variable.
Okay.
And then
So, yeah, so you could, take a plus b, store it to a temporary t, and then do t times t. All right, so it's tempting to take your code and make these low-level modifications to try to make it faster. But usually, it's a waste of your time. Now, why am I saying it's a waste of your time to do that stuff? Yeah?
Compilers automatically do that?
Compilers do that. Compiler sees a division by 2, it'll replace it with a bit shift. It sees you got shared sub-expressions, common sub-expressions, it'll do that. Compilers are really good these days at doing those kinds of low-level optimizations. So your goal isn't to do this low-level adjustments to make everything work better. It's to write clear code and let the compiler figure out how to make things faster. You don't want to rearrange things to the point where it's unreadable. So maybe in the old days, long enough ago, before compilers were very good, people did this sort of thing, but not anymore. As I mentioned, one way to tune your code is to switch from debug mode to release mode. And the compiler is more aggressive. When it's in debug mode, it doesn't want to, say, rearrange the orders of statements too much, because it makes it hard to step through your code to debug it. But in release mode, it can go to town on your code and really make it faster. There's a problem, though. You're essentially using a different compiler at that point. And what you want to hope is that if you do all your testing in debug mode, and then when you're ready to ship, you turn it to release mode and release it, the fact that it was compiled by a different compiler may have introduced a bug that didn't exist before. Now, how could a bug be introduced by a different compiler? Yeah?
Just kind of how it logically deals with maybe the different steps through the code.
He said how it logically deals with different steps through the code. So is the only way that you could end up with a bug, suppose you have a perfectly correctly running program, in debug mode, and then you switch to release mode and it doesn't work anymore. Does that mean that the compiler is faulty? Certainly a possibility, but it doesn't happen much. So how could this happen? Yeah.
Maybe the debug compiler was ready to deal with your mistake, but the shipping version is not going to be ready.
Well, she's saying maybe the debug compiler dealt with a mistake. Generally, compilers aren't going to fix mistakes. So, yeah.
Does it have to do with multi-threading, whereas in debug, maybe it's better making sure things go in order, whereas in compiler, things just don't
Okay.
happen in order.
So he mentioned the keyword, which is multi-threading. So in multi-threading, you've got essentially, instead of, if you think of, a finger moving through your code executing statements, you've got two fingers moving at the same time. And what happens when you're doing multi-threading can depend on where these fingers are. So if one finger is ahead of the other, your program may work just fine. If the other finger gets ahead, goes faster, maybe the bug shows up. And that sort of thing is, if you have a bug in your multi-threading, it doesn't show up all the time. It only shows up every now and then. It might be more likely to show up when it's compiled a different way. So with multi-threading, this is a real possibility. So at a minimum, you got to, before you release, you need to rerun the test in release mode. Yeah?
So we should generally assume that the problem is not with the compiler.
Yeah, you should generally assume the
Okay.
problem is not with the compiler.
Okay.
Yep. All right, so that's code tuning. All right, better algorithms to make a huge difference. So I do this all the time. I've probably done it in here. How much faster is binary search than linear search on a million-element array? Yeah?
A lot faster.
A lot faster, but I'm looking for a number. Rough number, yeah?
They'll be able to order logins that it's, well, on or then.
Yeah, but that's not a number either. Yeah?
You're looking for 500,000 divided by 20.
100,000 divided by 20, worst case. Okay? Or, no, a million divided by 20. Where'd that come from? How did we get 1,020,000? Well, basically, linear search. It's gonna, in the worst case, it's got to look at every element. It's a million things. Binary search just looks, as he said, at log n elements. The log of a million is about 20. So it's going to be 50,000 times faster on a million element array. So, I mean, it's easy to say, okay, this is O of n and this is O of log n. But you ought to at least be familiar enough with, these numbers that you can see. That's a huge difference, 50,000 times faster. On a billion element array, it'd be a billion divided by 30. So it would be, the difference is even larger. Right? Log of 1,000 is about 10. Log of a million is about 20. Log of a billion is about 30. So yeah, it's certainly worth it to, if your program is slow and you're doing lots of searches, do a binary search. But maybe not. If you only got to sort the array once, is it worth? If you got to only search the array once, is it worth it to sort it before you search it? No. A linear search is faster than a sort, so just do the linear search in that case. Got to be sensible about it. Array lists, why are they smaller than linked lists? Maybe you got memory problems. Yeah?
There's a lot of overhead involved in the list compared to array lists.
Yeah, he said there's a lot of overhead. A linked list is, the place to store the element plus a pointer here or a pointer there. Whereas an array list is just less memory overhead. So you save space. On the other hand, maybe you need a linked list because you got to do insertions into the middle. There are always trade-offs to consider. But you have no hope of making any of these trade-offs if you're not informed. If you don't know about binary search, you don't know about linked list or array list and how to compare them, you won't be able to make those decisions. Okay? System level decisions. The only way to benefit from hardware improvement is multi-threading. Now that was a completely false statement 20 years ago, but it's true today, more or less. Why do I say that? Why is multi-threading our only hope? Yeah,
Because our cores aren't getting much faster
good, right.
compared to the numbers.
So back in the 80s and 90s, every 2 years or so, the processor speeds would double. So they're making the processors smaller and faster, and that was just unsustainable. They finally realized that basically they couldn't keep making them faster and faster because they were going to melt. It was impossible to cool them fast enough. I think the statistic I saw was it was approaching like the heat density of a hot pad, a hot plate, and before long it would be the heat density of a jet engine. So that wasn't working, and so the strategy nowadays is they just put more cores in. So the cores are staying pretty much the same speed. They're just making them smaller and making more of them, putting more of them on the boards. So next year's computer won't be much faster than this year's computer on a core versus core comparison, but maybe there'll be more cores. So the only way to speed up your program is to have it run on more than one core at the same time. So if you have a program that's singly threaded, you can't spin your way out of it being slow. The way to make it faster is to use multi-threading. Yeah?
I heard something that like also the gains from faster clock speeds weren't as good, or like it tapers off, it plateaus. Is that true?
I'm just wondering what you mean by gains.
By like the performance increase for the amount of speed increase, it's like it plateaus. Like you can have a lot of increase in speed, but not a lot of increase in performance.
Oh, yeah. I'm not sure what to say about it. I don't have an observation about that.
Okay. All right.
So this is what I just said. Another thing that causes a problem with programs is file system latency. So you've got a singly threaded program, and it's got to read a file. It's got to stop in its tracks and basically wait and do nothing else while we wait for the file to be loaded, which can take a long time depending on where it's coming from. If we did multi-threading can also be an answer here too. So the idea up here, where we're increasing the speed of our program, the idea is we create 2 threads to do what we need to do, and we run each thread on a separate core. And then ideally our program becomes twice as fast. You don't get that reality, but you approach it. Here, you create one thread that waits on the file, and another thread that goes ahead and does something else. In that case, you don't need 2 cores. You need 1 core for the processing, and another core just periodically when that thread needs to be looked at. So threads aren't one-to-one with cores. And threads are a useful abstraction, it turns out, even when you don't have a multi-core computer. Because cores can schedule threads sequentially. We'll have a lot more to say about this. But these are the 2 big use cases we'll have in this class for multi-threading. To speed up programs by doing 2 things at once, and to make waiting more efficient, paradoxically. So we got these ideas about how to speed up our program. What should you do before you do anything? Yeah?
Get a benchmark.
Okay, he said get a benchmark. That's a good idea. Find out how, measure it so that, you can tell if you're getting better. Yeah?
Commit and make a new branch.
That's a good one too. Commit and make a new branch. I know I have taken programs that worked and broke them, trying to make them better. So it's nice if you can just ignore the branch and go back to where you came from. But there's another key thing that's missing. Yeah?
Know your hardware.
Say what?
Know your hardware.
Well, know your hardware. Yeah. And certainly if you're doing benchmarks, you need to do your benchmarks on the same hardware. Yeah.
Use a debugging tool to find out where you're getting hung up.
All right.
Target.
Okay, so we said use a debugging tool to see where we're hung up. It's not actually a debugging tool. It's called a profiler. So, don't optimize things that aren't a problem. I mean, you could look at a piece of code and say, yeah, this thing, I could make it faster. But if it's hardly ever being executed once at the beginning and never again, it's not in the loop, it's not worth your effort, probably. You want to figure out what are the hot spots in your program? Where is it spending its time? And concentrate your attention there. You may have a slow data structure, a bad algorithm. It doesn't matter if it's hardly ever used. And the way you make these measurements is with a profiler. So there's a profiler built into Visual Studio. And essentially, you run your program, you profile your program, it runs it, and when it's done, it'll show you all kinds of graphs and tables showing where the program spent its time, which statements did it spend the most time executing, how many times did it execute. And that's the subject of the lab tomorrow, is how to use a profiler. Also, before you get started, make sure you have good regression tests. In other words, make sure you've got a lot of good tests that can take the program as right, so that as you start modifying it and make it faster, you can keep running those tests and make sure you haven't screwed something up. We already mentioned committing your changes before you start. And finally, quit when your program has acceptable performance. So there's a famous saying that is attributed to a lot of people that goes, the perfect is the enemy of the good. You've got to have some notion of what's good enough. I mean, think about in the context of this class. You can never make your spreadsheet implementations perfect. I think you could always find something to improve. What should be your goal? If perfection is, or maybe you can make it perfect if you spend enough time. That'd be a waste of your time. You got other things to do. So, I mean, how do you make that decision in this class? What's good enough? Yeah?
When it's not like a hindrance to use, like if you're using it and it doesn't feel like
Okay, so he says, he's talking about the user experience and seeing, you know, it's not a hindrance, it's pleasant to use, I guess, yeah?
I don't know if I'm supposed to admit this, but I'm pretty sure I've got 98 points.
Yeah, that's exactly what I was after. You know, 98, it's great grade, so, you know, do you spend, and if it's taking you 10 hours to get the 98, do you spend another 10 hours to get the 100? No. The perfect is the enemy of the good. You do that, then you start failing 3810 or something. So you got to balance, right? You got to allocate your time, and time's a scarce resource. So I talked about profiling. It's, you know, simply put, it's a tool that measures where the program spends its time or consumes its memory. So you get graphs for both. Lots of details. You know, you can see them listed there, and you'll see them tomorrow. So it's a great way to find what are called the hot spots in programs, spots that could stand to be optimized. And there are two versions in Visual Studio. There's sampling. So the idea of sampling is the program runs, and the profiler just samples at regular intervals and sees where the program is executing. So it's statistical. It's not exact. But it's less invasive than instrumentation, where the profiler actually puts code into your program that's executed along with the other stuff that records the statistics. So two different approaches to doing it, and you'll experiment with both. And Visual Studio 2017 still provides a lot of this stuff, which is what you're looking at in the lab tomorrow. Okay? So I'm not going to try to demonstrate the profiler because it'll make more sense of it when you see it tomorrow. But are there any last questions about anything we've talked about here? Okay. Next topic. XML. Who knows what XML stands for? Yes?
Extensible markup language.
Okay, extensible markup language. So, if you're familiar with HTML, XML looks a lot like it. So, XML was designed to solve the problem of you've got data here in this program on the internet, and you need to share it with programs elsewhere. So it has to be shipped over. And furthermore, over the internet, the programs you're sharing it with may be written in different languages. So if I've got an array of objects, or say a linked list of objects here, and I want to provide a linked list of, a list of objects to use somewhere else, I can't just send you, I don't know, a map of my memory as the program is executing. I've got to send you the information in some language-independent way. So it's a language-independent way to represent hierarchical data. programming languages typically have utilities built in to read and write XML files. Now, XML was originally intended, as I just mentioned, as a way of a language-independent way of communicating data from different places. Nowadays, it's pretty much been replaced by a different thing called JSON. But XML is still used as a way to take information and put it in a form that can be saved in a file. So for example, if you use Microsoft Word or Microsoft Excel, when you save it, it's being saved in XML format. It's just a convenient way to store hierarchical information. So in your spreadsheets, when we get to the point of where you're saving your spreadsheet to a file, you'll be using XML to represent the state of the spreadsheet. And then you'll want to come back and look at what we talked about here. So that's the purpose we'll put it to, and that's the purpose it's still used for today a lot. So here is a typical XML file. So it's hierarchical in the sense that if you look at the indentation of this, it suggests the hierarchy. We have a tag at the beginning, an opening tag states. So that's like, you know, an opening HTML tag that says body. And here we have the closing tag. So you open, you close. Nested inside states are a bunch of state tags. So each state tag has an opening tag and a closing tag. And inside the state tag is a name one. And inside the name is the name of the state, Arizona. So we got lots of opening tags and closing tags. They need to match up and nest properly, like different kinds of parentheses and braces and such in a program. And then the opening tag can have 1 or 0 or more attributes, attribute name, attribute value. So that's an example of XML that represents information about states. In particular, for 3 states, it will tell you the name of the state and the capital city of the state. So let me ask you this. If we were to go to a place where XML is officially defined, would there be there a specification for how information about states is to be represented in XML? Not at all. We're free to invent. I just invented this as a way to represent information about states. In what sense is this XML then? If I can just choose any, I could choose different ways to represent the same information. What makes this XML? Yeah.
There's a rule set that you're still following that's generalizable or abstractable.
Okay, so she said there's a rule set that I'm following. Yeah, XML doesn't say give a meaning for state tags. I can pick any name tag I want. I can invent any attribute I want. I can put any values in it. But it says that if you open a tag, you got to close it. And before you close a tag, you got to close all the tags that were opened inside of that tag. And it does provide limitations on exactly what characters you can use as an attribute name or as a tag name. But beyond that, you can use this framework to, it's like a programming language, to describe the information any way that you want. So if I give this to someone, suppose I create this, I write a program that outputs this, and someone else wants to write a program to consume it. How do they have any hope of making sense of this? How do they know that the state name is inside of a tag and the capital city is in an attribute? Yeah?
Can you just open it in a file reader and take a look at it like a text?
He said they could open it in a file reader and look at it, or they just need to talk to me. If you're going to use my XML files, I've got to describe to you how they're structured. I mean, you could probably look at it and figure it out. But at some level, we just have to, we have to talk to each other so you can make sense of what I'm producing. So that's one way to do that information. Here's another way. Well, I guess there's another way, but I'm not going to show you right now. All right, so that's one way to do an XML file for states. I'll show you another version later when we actually look at some code. Okay? So here's another acronym, XALT, Extensible Style Sheet Language Transformations. And it's a language-independent way to describe how to transform an XML file into another format. Now, why would you want to take an XML file and turn it into a different formatted file. Well, let's see. This is a snippet, and you're not going to be writing any XALT. I just wanted to throw this in for completeness. Basically, you can think of this as this is getting matched up against the XML file that's coming in. And so what that's saying is, okay, every time you see a state tag, an opening state tag, then output that, this, go find the value of the name attribute for that state and stick it here. And then put that, and then go find the, this is the name, this is the value of the name tag, this was the attribute of the state tag. So you go find the capital attribute, stick it here, and then put those things out. What am I doing when I do that? Yeah?
That's an HTML table.
Right. What I'm doing is I'm converting, what this will do is convert my XML file into an HTML table. And in fact, what you can do with browsers, you can give the browser an XML file that contains your information. Now the browser can't display the XML file like you intended. You can also provide an XALT file whose job it is to convert the XML file into HTML. And the browser will actually run the XALT file, get some HTML, and display that to the user. That's one reason you do a transformation like this. So if we ran this little snippet on my XML file, that's what I get out, a piece of the table. So it's converted a piece of the XML file into this piece of an HTML table. So you can convert between formats. Yeah?
Now, does the target format have to be XML based, or could you like convert an XML file into like a C program?
Yeah, you could output anything you can describe. You could output. It doesn't have to be XML-like. I mean, you can see that HTML looks like a form of XML, doesn't it? You know, it's got the same nesting rules, and you can have attributes and so forth. All right. Last piece of the alphabet soup is XSD, XML schema definition. So maybe when you create your XML, you have some idea that there should be restrictions on it. So let's go back to this one. Okay, there's our XML file. Can you think of some rules you might want to impose? What makes a legal description of states? Yeah?
Capital and then name.
Okay, you could say that every state had better have a name tag inside it. If there was a state without a name tag, you could call that invalid. Okay, what's another restriction you might want to impose? Yeah?
Can exist more than 50?
He said there can't be, there's somewhere between 0 and 50 of these tags. You might want to do that, maybe not, but that's something you could consider. What else? So what do you say above and beyond the fact that the tags have to balance and all that stuff? That's a given. Yeah?
Maybe you want to protect certain variables or names or strings that you don't want them to be able to use.
Okay, you might want to say that the only tags you can use inside of state is name, or that there has to be an attribute called capital. So XSD is a way to describe that information. So you use that to describe what a legal XML document looks like, what a legal state XML document looks like. So that can be useful. So here, and again, you're not going to be writing these by hand, but that's a little piece of an XSD file, and the only thing I can read and know, well, I can read that you can have an unbounded number of state tags. There's no limit number of state tags. And here it's saying that the capital attribute is required. Now, why might you want to have an XSD file? What good is it? Yeah?
So that both sides know exactly what they're getting in a particular
Okay. So both sides know the rules. If I get your XML file, I can verify it against an XSD file description, make sure it didn't get garbled in translation. Now let me tell you how you'll be using XML. When you have to save a spreadsheet to the file, remember a spreadsheet consists of a bunch of cells, and the cells contain various information. So each cell will be a There'll be an XML tag that represents a cell, but you'll convert your spreadsheet into XML and save it to a file. I'm also going to have you create an XSD file that describes what a legal spreadsheet file is. Don't worry, there's an easy way to do it. Well, how will you use that? You're the one creating the XML file. Yeah?
When you go to open someone else's?
Right. If someone hands you a file and say, here's a spreadsheet description, before you do anything with it, you can validate it and make sure, yeah, this is a legal description. If it's not, if it's not a legal spreadsheet file description, you can give an error message and reject it. So the easy way I mentioned is it turns out that in Visual Studio, if you create an XML file, an example XML file, you can ask it to create an XSD file for you. Sort of a minimum one, but it would, that XSD file will describe what it sees. It would create some rules that correspond to what it's seeing for it. That's what you'll be doing. It's very simple thing to do. Okay? Now, still to come is I want to show you how you write programs that manipulate XML files, because that's what really matters to you. So we'll do that next, but first let's take a few minute break. Let's get started again. Okay, so now we're going to look at this stuff in action with the program. So, where do I want to be? I don't want to be in Eclipse. Okay, so here we have states1.xml. So this is an XML file I created, and you can see it there. So it's just pretty much, it's not exactly like the one I had on the slide. What's different about this one than the one I had on the slide? Yeah?
Capital's now a tag instead of an attribute.
Right, so name and capital are both tags, encoded with tags instead of using an attribute for the capital. So that's one version. And here's another one. This is states2.xml, and for it, you can see that we're using a tag, attribute for both of them. And the other thing you see is this, what this is called is a self-closing tag. It's the same thing as if you had this tag without the backslash, followed immediately by a closing tag. So if the body is empty, you can take this shortcut. Which is better? You know, you might say this is better because it's shorter, or you might say this one is better. I don't know, because it's longer. The point is, it's a matter of taste. It's not like one is right and one is wrong. Now, if you're going to be saving stuff to files, maybe it makes sense to make it shorter. And in fact, if you're saving it to a file, maybe you also wouldn't want to do the indentation. You could take all the white space out and actually save it. But the point is, there are just multiple ways of doing this sort of thing. Now, I'm going to show you another file. This is an XALT program. And again, you're not going to be writing this. So what this does is it matches the states tags, and then it extracts, it creates a table of state name and capital, and creates an HTML file from it. So it looks for the states tag, it starts outputting HTML, it starts outputting a table, it starts outputting a row, it outputs the first row in fact, and then every state gets turned into a row. And I can go here and run this, like there's XML, and I can say start XSLT, and there it runs it. Now what you didn't see is before class I had done this, and it asked me which XALT file do you want to run this against, and I picked it. So it just reads that file and outputs an HTML table. Okay? So that's the idea there. This one here, states2.xml, it's different. So you wouldn't run that translation file on this, because it's not assuming that organization. Here's a different one that expects, it produces the same table, but it's going to be a different description. And so if we run that, now it's asking for the input file for some reason. So I'll pick states2, and it runs it and gets the same output. And as I mentioned, that's something that can happen in your browser. If you give it both the translation file and the XML file, it'll run it and show the result. Okay, so that's interesting, but not groundbreaking. Here's the next one. This is states3.xml. And what do you notice about it? It tags the error right there, because what I did was I intentionally misspelled name to be name X. And the reason it is reporting that error is because up here, I've told it, this stuff tells it to use states3.xsd as its template file. And so it's detecting that error for me automatically. And yeah, there's even an error list down there. It says the required attribute name is missing, and I don't know what name X is. So it's wrong for 2 reasons. Now if I take out this stuff here, and the error goes away. It doesn't know it's an error anymore. It's only if you associate it with a template file that you see that. So for right now, I'm going to take this out because I don't need it going forward. So I'm going to keep it down here. So next year I don't have to recreate it, and I'll comment it out. I'm hoping here it's the same comment thing as HTML, which it seems to have been. Okay, so we're good. All right, so that shows you those three files in action. Now let's look at code that manipulates it. So let's go to XML.cs here. So just as I was saying with regular expressions, you're not going to be using this right away. So what you ought to be doing is trying to get an appreciation for how it works. But just remember, this is where you saw it, so you can come back and look at it when it matters in a few weeks. So I have a main method that, write example 1 creates the states1.xml. This one creates states2.xml. This one creates states3.xml. This shows you how to read states1. This shows you how to read states2. This shows you how to read states3 while doing validation. So I don't know if I'll actually run the programs, but if you want to run them, you can see how to do them here. Okay, so this creates states1.xml. So you see there's a class called XML Writer. So I'm creating an XML Writer object that's writing a file, and I tell it where to put the file. And one thing you should notice right away is it's nice and balanced, right? It says start document, here it says end document. It says start element, here it says end element. When you start an element, you tell it what it is, states. And then what's happening in here? So to put the actual state things in, we put a state tag there, we close it here. And what this does is it sticks in a name tag and a capital tag in between. So pretty easy to automate. You're just essentially nesting these calls to write start and write end the same way you want your XML to be nested. And you get to say what you want to call the tags, and this is just, I'm just reading that data from a few static arrays I declared up there. Yeah.
So for write element, are there also ones for like doubles or floats or?
Good question. Let's see. There are two overloads for this. So you can write a string. How does not show me? Yeah, there are two overloads, so there must be a way to write other things. Or maybe you've got to convert your double into a string and write it out. Okay, so that's that. So if you want to just do, this makes no use of attributes. It just nests stuff up, spits it out. So that's that. This writes the second one. So again, I'm using XML Writer. I'm creating a file. I start the document, I end the document. Then for each state, I create the state tag, I add an attribute, add another attribute, I close the tag. It's all pretty simple. Yeah?
What does the using XML Writer do?
All right. What does that do? Who knows what that does? Yes?
Does that close the input stream when you're done using it?
Okay, he said it closes the input stream when you're done using it. So if you've used try with resources in Java, where you have a try followed by an assignment or declaration that opens something that can be closed, then when the block is exited, when the block is exited, when we exit the using block, that writer will automatically be closed, no matter how we exit the block. So if we return, it's closed. If we just execute past the end, it's closed. If we throw an exception, it's closed. So when you open something nowadays, C#, Java, or similar languages, always open things with a using or a try with resources or what have you. Then you don't have to worry about it accidentally not closing it. Automatically close for you. Any other questions? this is, this right states 3. It's the same thing, except up here, oops. My program. The only difference is right here. So what's happening there? Why am I putting that into the root tag? Yeah.
It looks like you're requiring the state schema to be followed.
Yeah, I'm associating that state schema with this thing. So I just realized that when I was trying to remember before class how to associate a schema with an XML file, and I looked it up and I did that big long thing that I just added as a comment. But all I had to do was run this program. It would have recreated it for me in a simpler fashion. So that's an example of how to put the schema information directly into the document. So then it can be validated. Okay?
Yeah, I had a question about start element. So you can put multiple strings on the start of an element.
So right up there, the 3 parameters.
Yeah, the parameters.
Now let's see what it says. Right start element. Prefix. Yeah, so there are things called namespaces. And so that first parameter would be a namespace prefix, similar to that URN colon.
Okay.
So namespaces are a way to, so you can use tag names that may have a different meaning somewhere else, and you create a namespace that are separate. And I'm just choosing not to use namespaces. Right? So simple enough. Now here is one that reads. This is an example of reading an XML file. And there are various approaches to reading XML files, and if you don't like this approach, there are others. So essentially what's happening here is you just tell it what to do when you see each kind of tag. So when you see a states tag, nothing to do. You see a state tag, I just want you to output a blank line. If you see a name tag, then I want you to output state names equals, do a read operation, which will get the actual name of the tag, and output it, and then break. And same thing for capital. So it's sort of, you know, creating a lot of the control flow for you. Or it's the code that actually does the matching is being done for you. Well, I guess I should say the code that breaks up the XML file into things to be matched is being done for you. So what would happen if I ran this program? What kind of output would it produce? Yeah?
Every state would have 2 lines, one with its name and then its capital immediately after.
Okay. So it's just printing out state name equals state capital equals, state name equals state capital equal. So if I, let me go, let's go see if we can run it. So I need to go back here and actually choose it to run. So that's the one that reads the first one. So I'm going to do read example 1. And print, comment that out. And let's run it. Run. Okay, so that's the output it produces. It takes that file and pulls out the information and displays it for me. Now, if you wrote one of these, and you will, you wouldn't be printing stuff out. What would you do instead of printing something out as you took apart your spreadsheet file? Yeah?
Writing into a file?
No, it's already been written, and you're, say, creating a spreadsheet from. Yeah?
You can just like add it, like turn the text into formulas and things like that, and add it to the dependency graph.
Right, so you're going to have methods on your spreadsheet that allow the user to build spreadsheets. So you'll read the contents of a cell. You'll call the method that sets the cell to that value. So you'll be calling spreadsheet methods to build things up rather than printing things out. So that's an example of how to consume that one kind of thing. let's look at a different reader. So that's write example 1. Let me change this before I lose my place. I'm going to comment that out. And we'll go down to read example 2. So that's reading that other format where the state and the state name and the state capital are in the attribute. So it says when we see a state, put out a blank line, and then get the value of the name attribute, get the value of the capital attribute capital. So when I run that, I get the same information. It's produced a different way because the incoming XML file is organized differently. And finally, let's look at read example 3. And you can look at the code in here. This is where this is what causes it to be checked against this states3.xsd while the program is running. And remember, this file contains an error. So let's see what happens when I run the program. So instead of doing read example 2, I'm going to read example 3. And you can see, as my program was running, it noticed the error and it displayed the validation errors. Now, of course, if you were using this in your spreadsheet, you would find out there's an error and probably do a pop-up that says there was an error. And you probably would stop reading the file and you'd throw away any spreadsheet you created from it so far, because there's a problem in it. So let's see how that works. How does it detect the error? Write example 2, write example 3. Read 1, read 2, read 3. Okay, so in the configuration, you can see, we'll talk about event handlers later, but basically you're saying that when this is going to be validated using that XSD file. When the error is found, call that method with information about the error. And so what I had to do is tell it what method to call when it found the error. And then down here, I had to write the method. And I just wrote it so that if it gets an error, it prints out information about it. Whatever information I get about it, I just pass on to the user. So those are all the pieces that you would need to deal with XML files in your spreadsheet. You'd be able to write them out, which is really straightforward, and read them in, which is also really straightforward. And read them in while validating against an XSD file, which just takes a little more code. Okay? So before I leave this topic, are there any questions I could answer? Okay. Look at this one now. So, I can remember, I had an internship at IBM a long time ago, 1978, and that's back when IBM was like what you might get today if you combine Google and Microsoft. And it was basically, it was this huge company, the biggest company in computers. And I either saw a video or actually went to a meeting where they discussed code metrics. So the management wanted to be able to evaluate how efficiently people were working, who was the most efficient. And I think the metric they arrived at was KLOCs, which is 1,000 lines of code. How many 1,000 lines of code? How many KLOCs per year are various people writing? And you could think about, you know, if you were being paid based on how many thousands of lines of code you wrote a year, what would you do? You'd make your code longer. So it's not clear that measurement drives the right behavior, but you can see where they were coming from. They were trying to find some way to assess who were the most productive programmers and who wasn't. And so research has continued. And so there are various ways to characterize code quality. So one thing we talked about the first day of class were coding standards. So a business might have a coding standard, Google certainly does, and expect all the programmers to abide by it. So that helps improve code quality right there. Most organizations have code reviews. So what's a code review? Who's ever done a code review? Okay. So you want to say what it is?
You look through your code and make sure it doesn't suck.
How does a code review work?
Like you go with another person, you look at the code.
Okay. So that you get with other people, it's a meeting where you present your code. You know, you show your code and you explain how it works, and what are they going to do? Yeah, they're going to say, well, you know, that's confusing, that could have been better. You're just trying to get constructive criticism from people. And then later on, you get to be the one doing the reviewing, and someone else is presenting their code. So that's what a code review is. You sort of put it on the line, show what you've done, and get suggestions for improving it. So that's one way to improve code quality. Then there are compiler warnings. So in Visual Studio, there's levels of warnings that you get, not errors, but just the yellow things, numbered 1 through 4. So if you set your code warning level to 4, which you can do via the properties menu on the project, you're getting every warning that the compiler is possible can generate. And if you do put it at level 1, then you're getting the fewest errors possible, fewest warnings possible. So where do you think I have my warning level set? Yeah, that's set on 4. And yours should be 2. I'm not sure what it is. I think it must be, I reinstalled VS, so I think it must have come set at 4 by default, or maybe not. But you should set yours to 4. Because the more suggestions for improving your code you get, the better. Your goal should be to get rid of all the yellow, just like you get rid of all the red. There's also a tool in Visual Studio, I'll show you in a second, called code analysis. And for code analysis, using a variety of standards, it looks at your code and suggests ways of improving it that aren't things that necessarily have to do with compiler warnings. It's just ways to improve your code in general. Like it might say, that variable that you used right there should have that you call in, should be called something better, something more descriptive. Stuff like that, stuff a TA might say. And you can configure that. It has a bunch of different rule sets that can be used to analyze your code. You can choose which rule sets you want to use. 5 or 6 years ago, I had a student in this class that his policy was to always use the highest level of code analysis. And so for that level of code analysis, it's critiquing your code. Like if you have English words, if you have strings of text in your program, it'll ding you because it's not internationalizable. It's supposed to be, ideally it would be configured so that it's easy to switch from English to French to Spanish or whatever. And so every assignment, he would stick to this and make sure he get rid of all the complaints by the code analysis tool. And what would really drive him nuts is when I would give him the starting point code. And there was no way he could get rid of the code analysis problems with my code without modifying it. So, he would actually send me emails saying, could you please change this so that I can get rid of the 2 last bits of warnings. I didn't do it. Then there's code metrics, which are sort of an analysis of, I'll show you that too, an analysis of how complicated, it's sort of an approximation. It's an outgrowth of that 1,000 lines of code per year that I mentioned earlier. So, having introduced this topic, that's all there is to the slide, so I just want to show you this stuff in action. So we'll go back to Visual Studio, and we're going to go, I need to find a project to analyze, and I remember before class I was using inheritance.slm, so I'll use it. So that's just a project we looked at earlier. So let's look at some of these tools. Up here is Analyze. And I've got my choice. Under Analyze, I can run the performance profiler. That's what you'll be doing in lab tomorrow. I can run code analysis. I can configure code analysis. And I can calculate code metrics. So let's just run code analysis on my solution here and see what pops up. So it's building it. And it came up with some errors. And it's kind of small It's saying me that the constructor contains a cell chain that results in a call to a virtual method defined by the class. Review the call stack for unintended consequences. I'm not sure I've ever seen that one before. It may be an error I made. I didn't use this in class. It may be an error I made deliberately. I don't know. It's not telling me about much. So let's go back up here to Analyze and configure code analysis for solution. And I'm using Microsoft Managed Recommended Rules. So I'm going to change it to all rules. So we'll just pile on and see what happens now. So now I've reconfigured it. So I'll come to Analyze. I will run code analysis on solution. All right, I got a lot more. All right. And we can just look at some of them. It's telling me to sign the DLL with a strong name key. So it wants me to encrypt the DLL. Or not encrypt it, sign it so it can be verified if someone downloads it. You know, I don't care about that, but it does here. It doesn't like my variable name P. It doesn't like the N, the B. A lot of this is variable names. Culture info. Try running this on your own code and see what happens. Yeah, it's suggesting that I validate certain parameters before I use them. It's saying you've got this class that contains only static members, maybe you should mark it static. So anyway, it provides suggestions, and you know, some of them are irrelevant. So that's why you are able to configure it. Okay, let's try another analysis. Now I'm going to calculate code metrics for the solution. So I'll have to tell you what this says because it's small. But up there at the top, there are two projects, inheritance, not two projects, I guess two projects. Inheritance and rectangle. Over here is the maintainability index. That's the first column. And you can see the maintainability index of inheritance is 85. And rectangle, it's 87. So 100 is the best. If it goes below 20, you get like a yellow indicator. And if it goes below 10, you get a red indicator. And I Googled to see how this is computed, and it was kind of vague. Well, it wasn't vague. It just referred to measures that like Halstead's diameter or something, or Halstead's volume. And I didn't feel like looking up what Halstead's volume was. So it's doing something. And if you're curious, I didn't have time before class. Actually, I did. I went and wiped out one of my comments to see if my maintainability index would go down, and it didn't, so I don't know that it's looking at comments. Okay? Then there's cyclomatic complexity. So there, lower numbers are better. It's a measure of, what do you think? What do you think cyclomatic complexity, what does that sound like? Yeah?
How many branches and loops the code has?
Yeah, it has to do with branches and loops and exceptions. Essentially, how many, the more loops and conditionals and thrown and called exceptions you have, sort of the higher the cyclomatic complexity. And so if that's, I'm not sure exactly what the scale is here, but higher is worse. So ideally, you wouldn't have a really, if you got convoluted code, it's going to have a high number. Now, it needs to be convoluted for whatever reason. Maybe the problem is convoluted, but maybe not. So this at least would point you to places you could improve, possibly. If you expand out project, it'll show you the analysis separately for each class and each method. And you'd be able to pinpoint that the animal method seems to have the highest complexity of the spider method. The spider class, the animal class. And then there's depth of inheritance. That's easy to understand, just how deep does the inheritance hierarchy go. Class coupling is how many other classes your class references. The thought being that the fewer other classes you use, the simpler it is to understand. And then lines of code, there's our K-lock again, except here, more is worse. For a given method, a given class, everything else being equal, fewer lines of code would be considered better. So these metrics feed into that maintainability index along with some other rubrics. But again, if you've got the time and inclination to try to polish up your code, your sources of information, sort of unbiased, always available sources of information you can use to see what to do. I got one more thing to show you. Before I do that, are there any last questions about this? All kinds of tools out there to support software engineering. So it's good to learn about them and know they exist and maybe use them from time to time. Okay, final thing, it won't take long. Issue tracking. So what is issue tracking? Yeah?
Visual Studio is kind of like a to-do list.
Okay. So there's a to-do list. Basically, you can think of it as a to-do list. So anytime you're working on code, you've got things in your head, right? You think, before I hand this in, I got to add comments, or I got to add test cases, or I got to fix this bug, or I got to figure this thing out. And you can keep it in your head for a while. But as you get either older or your programs get bigger and your to-do lists get longer, you start to forget. So the simplest kind of issue tracking is just a list. And Visual Studio provides a way to do that we'll look at. And then it accelerates beyond that when you start working with other people. So now you've got a boss, and the boss has people under him or her, and they're all working on the same program, different pieces of the same program, and the group has to do the items to do. And so now a bunch of individual lists won't cut it. You need some kind of system to keep track of what it is you're supposed to be doing and keep track of when it's been done and who did it, which commit solved which problem. And so there are more involved tracking systems that let you do that. So I'll show you a way to do that you could use right now. So in Visual Studio, you may have noticed if you have a comment that begins with to do and then has more text, it's marked as a to-do list. It's marked as a to-do item, so it's highlighted in some way. But you can go look at the task list window, and it'll show you your to-do comments. So it's showing you here, there's a to-do on line 102. And there are other, you can also do, you can start the comment with to-do, or hack, or undone. I'm not sure how they pick these, or note. Or you can define your own tags. So there's a simple way to put your to-dos into your code and use this task list window so you can see what's left to do. And from the window, you can click on the to-do and be taken to where you need to go. So that's neat. Then GitHub. You're all using GitHub. Every repository has an issue tracker. And you can add new items. You click on new issue and it'll add to it. You can see right here that I'm looking at my issue tracker for this repository. And there's a demo issue here that says that was opened 2 minutes ago at the time by me. So people can add to this list anytime they want. So if you're working with a partner, you can keep your to-do list in GitHub. And this is what it supports. There are various ways to create, arrange, look at them, label them. So you can sort them by group, by individual, which is probably pertinent to you. You can cross-list them with tags. When events happen, like an issue is solved, you can arrange for email notifications. Various ways to search the issues. And this is a cool thing. If you have an issue, there's a way in your commit message, if you put the right sequence of letters, if you refer to the issue in the commit, it will automatically record that this commit solved this issue. It's kind of neat. And there's a GitHub plugin for Visual Studio. How many of you are using that? I know I see people doing it. So when you use Git from Visual Studio, you've got basically 4 options. You've got branches and changes and sync and settings. If you install the install the GitHub plugin, suddenly you've got more things you can do. And what that plugin lets you do, rather than you having to log into GitHub and looking at stuff in GitHub from the browser window, you can do it directly from Visual Studio with their plugin. And I suspect one of the things you can do is look at the issue tracking from there. So it just makes accessing GitHub a little simple. So you might try that out, that issue tracker. I'd really suggest that you try it out when you get to working in pairs. just a good central place to put the issues that you're working on. Okay, so today's, it's been a hodgepodge of tools and techniques. Where we're headed, probably next time, or if not that, next week, is talking about multi-threading. So that'll be the next big thing we talk about.